So we're going to be talking today about trigonometry beyond. Can you guys all see my screen? All good? So beyond 90 degrees, okay? So if you have an angle of 150 degrees, you have to draw this and you have to start from the positive x-axis and go counterclockwise. So that's how we measure angles from now on, okay? So you go 150 degrees like this, and that would be 150 degrees. Now, but when we talk about sine of 150 degrees, then we are not necessarily talking about a triangle that's in here, okay? So this is 150 here, right? So are we doing sine of 150 of this triangle? Not really, okay? What we're dealing with is sine of 30 degree there, okay? So it's so sine of 150 degrees is equivalent to triangle with 30 degrees on. So when you're doing sine of 150, you are dealing with a triangle with 30 degrees here. So it's a right angle triangle, of course. It's a right angle triangle with 30 degrees right there on the second quadrant. So let's have a look at what sine 150 is. So you need to know, first of all, that everything is positive on the first quadrant. Sine, tan, cos. So what this means is this. Everything is positive in the first quadrant. So this is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant, okay? Now, I'm going to show you why sine is positive here, but everything else is negative. Suppose you have like a point right there, and you have a triangle like this, and let's say this is equal to 150 degrees. So what is a sine of 150 degrees? The answer is that's a 30 degree there, so it's a sine of 30, but you can see that the sine of 30 degree is this one over this one, is that right? So the adjacent, the opposite over hypotenuse, true? So we can see that this height here is positive, isn't it? And the hypotenuse is always positive, okay? But this side is negative. I can show you. So this is negative, true? So if I do sine of 150, oops, hold on, yeah. Just erase it like that. So if I do sine of 150 degrees, then I get sine of 30. That's 30 degree there. And because it's a positive over positive, the answer is positive. So I'll put a positive sign there, and this is equal to 1/2. All right? But if I do cosine of 150 degrees, so cosine of 150 degrees, then this is equal to you can see it's that one over that one, true? So it is equal to, pretty much equal to cosine of 30, okay? So that becomes that, but you have to put a minus sign because that divided by that would be negative, of course. And for this one, cosine of 30 is actually equal to root 3 on 2. And you have to put a minus sign there. And tangent is this one over this one, so it's negative, right? So only sine is positive there. We're going to talk about, for example, 200 and let's say 10 degrees, okay? So 210 degrees is, so that's 180, and then you go 30, right? So we're dealing with a triangle over here. Just one thing you have to know is, so this is very, very important. And another thing that's very, very important is this one. So you might want to write it down. We are always dealing with a bow tie shaped triangle. This one here. So we only care about this angle, this angle, this angle, this angle. So they're all the same. Okay, so that's x, this is y, and we only want the bow tie triangle. So at the moment, we're not dealing with this triangle, or this triangle, this triangle, or this triangle. Just remember, we're dealing with bow tie triangle, okay? So that's number one thing. And another thing you have to memorize now is, so try to memorize this one, sine of 0, 30, 45, 60, 90 degrees of cosine of tan. So what's a sine of 0 degree? That's the answer is 0. What's a sine of 30? The answer is 1/2. The answer is sine of 45 is root 2 on 2. So this is something you have to memorize. And this is 1. And the rule for cosine, it goes the other way around. So this is 1. This is root 3 on 2. This is root 2 on 2. This one is root 1 on 2. 1/2, and this is 0. Tangent goes 0. 1 on root 3. 1, root 3, and this is infinity, okay? So this is something you have to memorize. I'll give you the reason for this one. So let's say you have a 30. This is 30. This is 90, and this is then 60, right? So when you have a 30, 60, 90 triangle, this is a very famous triangle. If this side is 2, this side will be 1, and this side would be root 3. Okay, so whenever you guys get confused about this one, just draw this one, and the hypotenuse is the longer side, which is 2. And 2 is greater than root 3, by the way. All right. And the shorter side is the one that's corresponding, that's opposite 30 degree, okay? So that's 1, and the root 3 is the second biggest, and that's the one that's corresponding to 60 degree, okay? So the one that's opposite to the 90 degree is 2, that's the biggest one, okay? Now you can see here, what's the sine of 30 then? What's the sine of 30? That's a 1 on 2, isn't it? So that's why you get 1 on 2 right here. What is equal to cosine of 60? Cosine of 60 is also, you can see that this is the angle, so that's adjacent over hypotenuse, right? So that's also 1 on 2. So because everything, sine of 30 is this one, cosine of 60 is this one. So they're actually the same. That's the reason why you have a sine of 30 is equal to cosine of 60. You see that, right? Let's go and have a look at another one. If you look at, let's say sine of 45, we're not dealing with 45. What's a sine of 60? So that's a 60 degree here. That's opposite over hypotenuse. That's equal to root 3 on 2, right? Well, what is equal to cosine of 30? Cosine of 30 is adjacent over hypotenuse. So this is also equal to root 3 on 2. So you can see that. Sine of 60 degree here, so that's a sine of 60 degree right there, and cosine of 30 degree. You see, they're actually matching, right? So these are the values that we can find from this triangle right here. Okay, now we're going to look at 45, 45, 90 triangle. Anybody any questions so far? Any question? Philip and Chris, do you follow this pretty well? Okay. What about Philip? Not too bad? Not really? Okay. For now, you just have to know that you just have to memorize these values. That's all. Okay. So it's not a difficult thing. Just try to follow as much as possible. And if you don't understand, then you can always organize like one-on-one tuition. All right, then we can go through some of the things that you don't understand. Lizzie, do you follow this very well? Quite well? Elizabeth?
Yeah.
Okay, good. You follow everything, yeah?
Yeah.
Okay, now we're going to go for a 45-45 triangle. So if you have a 45 degree triangle, this is 45 here, that's a 45 here. then if you have a 45, 45, and this is 1, 1, then this will be root 2, okay? The reason is, if you look at Pythagoras theorem, like this is c squared, a squared, b squared, right? Then if this is 1, so c squared is equal to 1 square plus 1 square, right? Then you get c squared is equal to 2, and c is equal to root 2. That's why if this is 1, 1, then you get root 2 here, okay? So what is equal to sine of 45? Sine of 45 degrees, that's equal to this over this, right? So that's 1 on root 2. What is equal to cosine of 45 degrees? That's cosine of 45 is that one over that one. We can use, if you're using this angle here, then you'll be doing this over this. Alright, so they're actually the same value. Now, you can also rewrite this one. You can rationalize this one by multiplying top and bottom. So you can see that 1 on root 2 times that by root 2 on 2. So you can multiply top and bottom by the same thing. This is essentially multiplying this by 1. This is equal to root 2 over root 2 times root 2 is just 2, right? So this is the same thing as root 2 on 2. So this is root 2 on 2 right there. So that's why I wrote sine of 45 degrees is root 2 on 2. Root 2 on 2 right there, okay? Now, let's go for tangent right there. So what's a tangent of 30 degree? Tangent of 30 degrees right there. This is tangent is opposite over adjacent, isn't it? So tangent of 30 is that one over that one. So that's why we get 1 over root 3. This one here, which is that one, that over that. And what is equal to tangent of a 60 degree? Tangent of 60 degree, you know, that one here. Tangent of 60 is this one. Tangent of 60 is that one over that one, true? Opposite over adjacent, so that's why you get root 3. And other values here you have to memorize. So there's a very good trick to memorize these values. So if you have, so 0, 0, 0, memorize that. That's a 1, minus 1, 1. All right, so this one here is cosine. Okay, this one is sine. Okay, so 0, 0, 0, 1, 1, 1. And this value here is 1 and minus 1, whereas this one here is 0 and minus 1. So what is sine of 90 degrees? Sine, this is 90 degree here, right? So you go this way. Angle always starts from the right positive x-axis. So this is 90 degree there, and you get 1. So the answer is 1. What is the sine of 0 degree? That's equal to, that's 0 degrees right here, and the answer is 0. The sine of 0 degree is 0. And what is the sine of 180 degrees? The answer is negative 1. So that's a negative 1. And sine of 270 degrees is equal to, hold on, no, this was supposed to be 0, sorry. It's a 0, 0, 1, minus 1. So this is 0 here as well. And 270 is minus 1. What is a cosine of 0 degree? That's this branch right here, right? Cosine of 90 degree, cosine of 180, cosine of 270. So these are 1, 0, minus 1, 0. 1, 0, minus 1, 0. So those are the values that take care of these things here. So what we just did here, all this, takes care of, not only takes care of this value, and this value, but it also deals with, like this is 0 degree, right? This is 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, right? So this one goes beyond this table. So this is only 0 degree and 90 degree, right? But here we are dealing with 180 degree and 270 degree as well. These two as well. Okay? So that's what you use when you have something more than 90 degree here. So this is something you have to memorize. This is something you have to memorize. if you want to do well in year 11, and this is something you have to memorize as well. All sine, tan, cos. So we memorize this as all. What was the mnemonics for this one? Yeah, C-A-T-S, cats. I think C-A-T-S. So that's what you memorize. That's how you memorize. In most textbooks, I think they teach C-A-T-S. Now, so this is all sine, tan, cos, so all cats. Cats, C-A-T-S. This picture right here is 000, 111. That's for sine, this one's for cos. And you memorize this picture here. And you also memorize this one here. Okay, we're not doing this one yet. We're doing this one right here. Just a quick question. Is any of the video and audio breaking at all? Is it breaking much or pretty good quality?
Pretty good.
Pretty good? Okay. All right, so for example, suppose you have sine of 270 degrees. What do you have to do if you want to evaluate this value? You have to, in this case, you have to use this picture here. So this is 270 right there. That's 270, true? So that's a -1 right there, okay? Sine of 270 is, yep, -1 right there. So this one goes, this one's for that one, this one's for that one, okay? Let me just double check. 0, 1, 90, 0, -1, 0. 0, 0, 1, yeah, that's right. So sine of 270 is -1. So you can just get the answer straight away, like that, okay? So if you have sine of, let's say, 200 and, let's say, 25, then you first have to figure out where 225 is. So 225, this is a 180, and then you go 45 more, then you get 225. So that's number one, what you have to do. Number one, you have to draw the branch. Okay? And then you have to figure out what the angle is. You have to draw the bow tie triangle. You see, this is one of the triangles in the bow tie, true? So you have to figure out this angle right here. That is 45 degrees, right? So this is equivalent to sine of 45. But the thing is, sine of 45 this is an angle that is always, this is less than 90 degree, right? So as long as they're less than 90 degree, you can see that from this table, they're all positive, right? But sine of 225 may not be positive. All right, as you know, this is all sine, tan, cos. Only tangent is positive right there. The reason is, you can see when I draw a triangle like this, what is a sine? Sine is opposite over the hypotenuse. That's a negative. You can see it's down. And that's a hypotenuse, which is positive. So that's negative. This one divided by this one is sine, and that's negative, as you can see. So because this is where tangent is, you have to put a minus sign there. Okay? So the answer is, so you might want to use your calculator now and verify this yourself. Calculator. So have a look. So I'm going to put my calculator into degree mode, by the way. So this is in radian mode. I'm going to talk about radian in a minute. So degree mode. So what is the sine of, what's the sine of 225? The answer is that, negative 0.70, like 71, negative 0.707. And let's see if sine 45 is positive of that, okay? So sine of a 45 is equal to this one, right? So that's why we have to put a minus sign, because this one was negative, right? So this is equal to negative, and this was positive, right? So 0.707, then you get the answer. So you can reduce this very high angle into some lower angle like this. So maybe try this one, sine of, let's say, 500 and let's say 690. 690. So you can reduce this to a lower angle, okay? So what you have to do is, number one, you have to draw the branch, and then you have to figure out the angle inside the triangle, okay? Number two is draw the branch. Number one is draw the branch, and you have to draw the triangle, which is one of the triangles in the bow tie shape. So I want you to have a go with this one. I'll give you maybe 1 minute to try this. 1 minute. So all you got to do is just reduce this to some lower acute angle. Okay. All right, so we have to draw. So if you go 360 degrees, right? So that's around that. So it's let's do 690 minus 360 first. So then you get 330. So 330. So it's a 360 and then 330 more, right? So that's going to end up right here. So I drew the branch, and then I have to drop down my feet toward the x-axis. Then I get this triangle. So because this is 330, this must be 30 degrees right there, 30. So this is equal to sine of 30 degrees, but that's of course positive. So we have to figure out whether it's positive or negative. So sine of 690 is right here on the fourth quadrant. And on the fourth quadrant, only cosine is positive, right? So you have to put a minus sign there. Okay. Oops. Yeah, minus sign there. Maybe I can make another layer. That way I don't have to. I can just use eraser. Okay. Okay, now let's move on to, so this is how you work out. Let me go through another concept, another thing. That is, if you have, oops, it's not drawing. Hold on. Number 6 is yellow. I think I like yellow. Okay, so let's suppose you have this one. Let's say sine of some angle is equal to 1/2. Right? So this angle, we know that, sine of 30 is 1/2, right? But somebody can ask you, what is the sine of 90 plus theta? That's going to give us 90 and then theta, right? So then this will be theta instead of this being theta. So we cannot draw a triangle that way and call this one theta, right? So we have no choice, but we have this triangle and that's theta, or understand? So if you end up getting, instead of bow tie triangle, but you get this triangle here, okay? Then what you have to do is the sine has to convert into cos, and cos has to convert into sine, and the tan has to convert into cot. I'll tell you what cot is. Cot is 1/tan. All right? But if you get the angle inside the bow tie shape, then sine, you can preserve it. Sine is sine, and cos is cos, and tan is tan. So you don't have to worry about them at all. So that is the reason why we have sine of 690 is sine of 30, negative. But now let's have a look at this one. So what's going to be this guy? So we have this triangle here with that angle there, so we can use that theta, right? But sine has to convert into cos, is it right? Therefore, what is cosine of theta? So we can see, let's have a look at it. Let me think about this. So you got so let's say this is the condition. So the condition given, so this might be a bit difficult to understand. I know, it's a bit advanced. So let's suppose that this was given and cosine theta was given as, of course, root 3 on 2, right? Because it's 30 degree. Then you can answer this one as, so that one turns into cosine. And that one here, hold on, this must be negative though, because all sine, tan, cos. Just give me a little bit of time. It's a bit confusing to me as well. 90 plus theta. Oh yeah, it must be positive, of course, yeah. So the answer is positive. Let's think about this, okay? Is that going to be positive or negative? Root 3 on 2. Let's think about that. The answer is positive. Okay, even though so this quadrant right here is, this is sine, only sine is positive, right? But we got cosine here. So do we have to use minus sign because it's cos? The answer is no. The original thing is sine, isn't it? The original one is sine. So therefore, this is where sine is positive. So therefore, it must be positive. Okay. So this is an advanced topic here. Advanced topic. So we'll go through this one more later. Advanced topic. Okay. We're gonna try a few questions from the textbook. So let's have a look. So this is page 441. I'm gonna go for 441. So this is about there's a summary there. These are talking about some things that we didn't talk about. Okay. Maybe it's the end of chapter 13. Chapter 13, no. Okay, maybe we should study more before we do those questions. Okay, now we're going to talk about now radians. Radians versus degree. So from up to year 10, you guys deal with degrees, right? So degrees, like 0 degree, you guys know what 180 degree is. You guys know what 360 degree is, right? But you should know that why should 360 be 360? Why is one revolution known as 360 degrees? Why not call it like 100 degrees, you know? So who made this number up? Probably like ancient Babylonians, okay? Who were like genius in mathematics in the ancient time. Why did they use 360? Probably because 360 is divisible by 2, divisible by 3, 4, 5, 6, and 8, and it's divisible by 9 as well, 10, 12, etc., etc. So it can be, you know, divided into many different parts, many equal parts, you know. So that's probably the reason why 360 was chosen. And probably that's why, you know, 1 hour is 60 minutes. So this is where it all comes from. 60 minutes, 60 is a number that's also divisible by many, you know, different numbers. And so is 24. So 24, you see, 60 minutes and 60 seconds, you see. I think all of that, comes from the 360. I'm not sure who actually invented this number, okay? But let's move on to radians, okay? So degrees is actually mathematically not so significant, okay? Well, we're going to get the definition of degrees, okay? Angle, definition of angle. So now angle was just a number before, but angle is now going to be defined as L over R. So this is arc length over radius. So I'm recording this video, so I'll encourage you guys to watch this video again, the recording again, to if you find this this topic pretty difficult to understand. All right. Now, because we like going through this really fast. Now, so if you imagine you have a small circle and you have a big circle. Suppose you have this is small radius and you walk along this circle. Let's say this is like 1 meter, and you walk along this circumference 1 meter as well. Then it's going to form an angle there, right? Suppose this is a 2 meter circle, so radius is 2 meters. And you walk along the circumference, also 2 meter much. Then you're going to also form a little angle here, right? So the question is this: would these two angles be the same? This is here 1 meter by 1 meter. This is 2 meters by 2 meter, right? But they're different circles, by the way. So would these angles be the same? The answer is yes. Okay, they are about 53 degrees. I'll prove this to you, okay? So this is 53 degrees. So, how do we prove that this is 53 degrees? Okay. Have a look. So we know that 2 pi r is the circumference, right? Circumference. And think about this one. So if you have, hold on, let me just close it though. So 2 pi r is circumference, and so this is C, and area is given by pi r squared. So that's from like year 10 maths, right? Now, I want you to think about, so this bit here, so let's call that L, all right? So L divided by 2 pi r. So that's L divided by 2 pi r, that's a whole circle, okay? That would equal to this angle, whatever that angle is, divided by 360 degrees, right? Because the circumference that corresponds to 360 degree is 2 pi r, of course. So 2 pi r is the same as 360. I mean, equivalent. And this L is sort of equivalent to this theta, isn't it? So if we figure out so we know that the L is 2, right? So what we get is, you multiply 360 over here, then theta is equal to L times by 360 over 2 pi r. And this is 2 meters, and radius was 2 meters, right? 2 meters, 2 meters. So what you get is 360 divided by 2 pi. So that's your theta. So let's try 360 divided by 2 pi. 2 times by like 3.14. Then you get about 57. So I was a bit wrong. This is actually 57 degrees. So you get 57 degrees. So no matter what the size of the triangle is, so you may have like you can have like a very small circle, and if you have, this is radius r and you have radius here L, and if these two are the same, if this is 1 by 1, or in this case this is 2 by 2, this is 0.5 by 0.5, have a look. So if L and R are the same, then these two will cancel out, and you see the angle will stay the same. Angle is going to be always 360 over 2 pi, isn't it? So this angle is always going to be 57 degrees, which is given by 360 divided by 2 pi. Now, from now on, we are going to call this 1 radian. So 57 degrees is the same as 1 radian, okay? So 1 radian is 57 degrees. And also, it is, you can see that when these two cancel out, this is 180 divided by pi, right? So this is 180 divided by about 3, so that's why you get 57 degrees. All right, so 57 is, degrees is this much, which is equivalent to, if we're going to have a new unit. I'm going to give you this question here. Suppose 0.75 US dollar is equal to 1 Australian dollar, AUD. Okay. Now I have 125 AUD. I want you to convert that into US dollar. And I have 125 US dollar, and I want you to convert that into Australian dollar. Try that. This is a simple unit conversion lesson, okay? Unit conversion. So give you maybe 1 minute to try. So this one here is 1 US dollar. 1 US dollar is, yeah, that's correct. 1 US dollar is about 1.5 AUD. That is correct. So you can calculate that from this one, of course. Okay. So here's how you, so Chris worked this one out, but we don't have to work this one out, okay? So it's very simple. If you have 125 Australian dollar and you want to convert that into US dollar, then all you have to do is, you see 1 AUD goes to the bottom, and so 1 AUD is actually the same as 0.75 US cents, right? 0.75 US dollar. So you have to put it like that. And what happens is the US dollar and US dollar cancel out. I mean, AUD cancels out, then you get US dollar. So the answer is just 125 times by 0.75. Then what you get is $93.75. Now, this one here is quite simple as well. So if you have a US dollar, then you have to cancel US dollar and have AUD on top. So you can see that the 1 AUD is the same as 0.75 US dollar, right? So this one is actually the same as dividing by, 125 divided by 0.75. Then you get $167 about, $167, okay, in Australian dollar. So here's the thing, if you want to convert unit, so this is very important in physics and chemistry and maths as well. If you have a unit, like unit A, and you want to convert it into B, unit B, all you got to do is just put A here and B here, and this here is the same as this one. So you see, $1 is the same as 0.75 US dollar. And here, $1 is 0.75 US dollar, right? So you can also create, just like Chris did, you can create another unit conversion factor. So this is a conversion factor. So that's a conversion factor here. This is a conversion factor. Now, have a look. So we know that 1 AUD is 0.75 US dollar, right? So you can convert, if you just divide 1 by 0.75, so what is a 1 divided by 0.75? Then you get 1.333. So it's a 1.333 AUD 1. So you can see that 1 divided by this is the same as this divided by this, right? So you can convert it into that. So what you got here is this. 1 AUD is same as 0.75 US dollar. Or you can say 1 US dollar is 1.333 AUD. So you can use, this is the same conversion factor, okay? So I think Chris got it wrong before. So 1 US dollar is actually 1.333 AUD. So you can just calculate it like that, okay? So you can use this factor instead of this one right here. So let's try. So 125 times by, so we are digressing a little bit, but doesn't matter. So it's AUD. Yeah, this is very important because even though we are digressing a little bit, this is going to be very, very useful for your future study. So I got 125 AUD. I cancel that out with AUD, right? And US dollar on top. So I'm going to use this one here rather. So it's a 1 US dollar. See, 1 US dollar is 1.333 at the bottom. So 1.333. So I can do that. I can just multiply this by this. So 125 times by, divide this by 1.333, then you get 93, which is exactly this one. And you can do 125 US dollar, and you multiply this by this one. So AUD go on top and US dollar go on the bottom. Then you can do 125 times by 1.333, then you get 166 as well. So if you round that up, it's 167, so the same as this one. Now, we're going to go back to this one now. So, this one right here is 57 degrees, but we're going to call that from now on 1 radian, right? So if you go for 2 radian, this is about 2, right? 1 and 2. So this is 2 radians. I mean, that's also 1. So it's 1 and 1. If you go for 3 radians, so that's about 3. That's 3 radians. So what about this one? So this bit is about 0.14. Okay. So this is total about 3.14 radians, right? But that's equivalent to 180 degrees, true? But 3.14 is actually pi. Is that right? So what you have to remember is that pi radian is the same as 180 degrees. Pi radian, so that's a different unit. Just like, you know, when you have like 2.54 centimeter is equal to 1 inch, you know? Just as we, you know, when you have a different unit, we have different numerical value. So when you have a different unit, radian and degrees, we can have different numerical value, and they're sort of equivalent. What this is saying here is that 2.54 is of course not the same as 1, but 2.54 centimeter is the same as 1 inch. We're going to move on to the next idea. So you know how we wrote this before, like 0 degree and 30 degree and 45, 60 and 90, and sine, cos, and tan. So from year 11, you'll be using 0 radian, and 30, so 90 is pi on 2, because pi is actually what? 180 is pi, true? So 360 is 2 pi radians. 90 degree is just half of this one, right? So this is pi on 2. If you divide this by 3, then you get 60, right? So divide this one by 3, then you get pi over 3. This is pi over 4, and this is pi over 6. Okay, so that's 30, that's 45. This is pi over 4. Okay, so, and the table is still the same. What's the sine of pi over 2? The answer is 1. What's the sine of 0? 0. This is also 1 on 2, root 2 on 2, root 3 on 2, etc., etc., okay? So you can, you now have to work with these guys here. So this is the introduction to radians. We got 10 minutes. I'm going to explain more stuff, and then we're going to move on to problem solving. Okay. Now there are a few very convenient formulas you can use using radians. Okay. Suppose this is 30 degrees and this is, let's say, 4 meters. Then how much would be this length right there? So I want you to think about that. And also, if you have, that's 4 meters, this is 30 degrees, what's going to be the area here? So I want you to use your knowledge and think about this one. I'll give you maybe 30 seconds to think about this. So I'll give you a clue. The idea was you just work out the total circumference, 2 pi r, total circumference. So 2 pi r is to 360, just as the L, this one here, is to 30 degrees, right? So this is to 360, just as this is to 30 degrees. I hope that makes sense. And in this case, pi r square is the area of the whole circle, is to 360, just as this area is to 30 degrees. And I'll give you some rule. If you've got A, B equals to C to D, then AD will equal to BC. So I'll give you an example. We know that 4 to 2 is the same as 2 to 1, right? So do you notice that this times by this is the same as this times by this, right? So using that idea, I want you to try this. I'll give you, and this one as well. So I'll give you maybe 2 minutes for these two questions. Okay, let's try this. So if you use this clue right here, then this one times by this one is same as this one times by this one, right? So 2 pi r times by 30 is equal to 360 times by L. So what's this L? This L is equal to just a 2 pi r times by 30 divided by 360. So you can write that as 2 pi r times by 30 over 360. That actually makes sense because this whole thing is 2 pi r, right? But then you want a fraction of that 2 pi r, right? And that fraction is 30 out of 360. So if you do that, then you can figure out this L. So I can just work that out here. So this is 4, by the way. So this is 60. So this is a pi r over 6. And r is equal to 4. So this is a 4 pi over 6. So that gives us 2 pi over 3. And that's in meters. So this is 2 pi over 3. Okay? Is that clear? Chris, do you understand? Elizabeth, do you understand?
Yeah.
You do? Chris, Philip? Not so much? Okay. Well, let's try this one here. It's also very similar, and then you might be able to understand this one. So the area, so let's try this. This times by this is a 360A. 360 times by A. And this is a 30 times by pi r square. So area is equal to, so always remember this. When you have like a ratio like this by this is equal to this by this. So that's a very, very useful formula. So this by this is equal to this by this. This is equal to 30 pi r square over 360. But this is the same thing as 30 out of 360 times by just that one times by pi r square. So this one here, what this area means, what is this area? So this area is, this total area, pi r squared is the total area, times this by the fraction, which is, this is a 30 out of, so this area corresponds to 30 out of 360, right? So that, there you go. So this is the formula. So this is a pi times by 4 squared times by, this is a 1 out of 12, right? That's what 30 out of 360 is. So this will be 16 on 12 pi, which is a 4 pi over 3. And this is going to be meters squared because this is area. All right. So this is rather a bit complicated, but we have a very convenient formulas when you are using radians instead. Okay. So just write this formula down. So if you want the L, which is the arc length, so because theta was defined as L over R, so that we defined radian angle. So when you have, for example, if you have 2 meters and you go here 2 meters, what was this angle here? This was 1 radian, right? What's the reason for that? Because the definition of the angle is now L over R. So L over R here is 2 over 2, right? So that's equal to 1. True? So if you actually rewrite, if you move the R to the other side, then you get L equals to R theta. Is that right? Now have a look. What was R in this question right here? This was 4, right? 4, and the angle was 30 degrees. So we had a circle with the radius of 4, and the angle was 30 degrees, and we want to figure out this L. But what this question is, what this formula is saying is this: the R is R times theta. So R is 4 times by theta. How much is theta? Guys, how much is theta? I want you to answer that. It's 30, right? But we are not supposed to use 30. We have to use the radian angle. So the radian angle is pi over 6. Because why? You know, a pi is equivalent to 180 degree, right? True. So if what's a 30 degree? 30 degree is this one divided by 6. So we have to rather multiply by this number here. Then you get 2 pi over 3. Was that the answer that we got here? That's what we got here, you know? So 2 pi over 3 meters. Is that true? Now we also have a very famous formula, so very convenient formula for area. Area is equal to simply half r squared theta. I'm not going to go through derivation of it. Just memorize this one and use it. So it's a half times by r is 4. So that's 4 squared, isn't it? 16. Times this by theta. Theta is pi over 6 again. So this is equal to 16 pi over 12, which is equal to 4 pi over 3. That's in meters squared, okay? So you get that same answer. So formula for this one is the arc length is this one. You got the area here, okay? Now we're not going to go through an interesting thing. Chris, the 30 degree is pi over 6. Pi over 4 is 45 degrees. Okay? Like this one. Alright. It's 7 o'clock now. So we're going to try some questions. So we went through this, all of this. Alright. Okay. So here's another formula. If you want to convert degrees into radians, so radian angle is with C up there. Okay, so this is a circle, that's a C. You simply have to multiply this by pi over 180 degrees. The reason is The reason is the degree and degree has to cancel out, okay? And we know that 180 degrees is equivalent to pi, just as like 1.25, 0.75 Australian dollar was equivalent to 0.75 US dollar was equivalent to $1 in Australia. And if you want to convert theta radians into degrees, then you have to multiply this by 180 degrees over pi. So I'm going to give you question 1. So question 1, it's actually not pasted here, but let's suppose we have 102 degrees. How do you convert that into radians? You simply have to multiply this by pi over 180 or 180 over pi. The answer is pi over 180. Pi over 180. So you can try this as 102 divided by 180 first. So that's going to give you some decimals in your calculator. So if you include pi, it can never give you decimals like that. I mean fraction like that. So this is 17 over 30, isn't it? So 102 over 180 is 17 over 30, and then you just have to put pi next to it. Okay? So this is in radians. So you can express exactly, so this is in an exact form. So I'll show you the non-exact form, okay? Non-exact form is, you just have to multiply, just have to evaluate 17 pi, I'm just going to move this one up a bit, okay? 17 pi over 30. Then what you get is 1.78. So if you just write 1.78, of course the decimals continue, but you just have to, for a non-exact form, of course, you have to stop at some point, whether it's 2 decimal places or 3 decimal places. So that's how you do it. But of course, the exact form is more preferred, okay? Much more preferred form. Now, number 2. Let's try f. So this one here says f, that's 11 pi over 12. So 11 pi over 12 is, you want to convert that into degrees, then you have to multiply this by pi down here and 180. So this is completely opposite to this one right here. So this is pi cancels out, and I think you can just multiply this along. So this is 11 times by 180 divided by 12. So 11 times by 180 divided by 12. So that's 165 degrees. Okay, so that's how you convert all this. Now we're going to try this one here, number 7. Number 7. So with the aid of calculator, so I want you to take out your calculator and go on to like setting, and then convert this into radian. Okay, so if you've got regular Casio calculator, you just have to press shift and then go to setup, and that can turn this into maybe you can press number 3 or 4 to change between degrees and radians. So you can just put tangent of pi over 10 straight into it. So my calculator is in radian mode, so I can do tangent of pi over 10. That gives me 0.325. 0.325. But obviously this is equal to, 180 divided by 10. So, pi is equivalent to 180. So there are 2 possible ways of converting this radian into degrees, okay? So have a look. You can decide which one is more convenient. So we know that the conversion factor is, this is radian. So I need to put pi there and then 180. This is what I taught you up here, right? So you can see that this cancels out and you get 180 divided by 10. So this is equal to 18 degrees. So tangent of pi over 10 is the same as 18 degrees. And you can just change this calculator into the degree mode and plug in tangent of 18, then you get 0.325 again. So this is one way of changing this pi over 10 into 18 degrees. You can, however, just substitute 180 into pi. So what's 180 divided by 10? That's just 18 degrees, right? So that's another way. So 100 pi over 10 radian is simply 180. Just replace that by 180. Then you get 18 degrees. Okay, so you can just try all of this yourself with the calculator, but make sure that these are all in radian mode when you're dealing. These are all radians, right? So whenever pi is involved, that's all radians. But these are also radians, but they don't involve pi. So it doesn't always have to involve pi, all right? But if pi is involved, definitely it's radians. But if it's just numerical values like that, it could be degrees or radians. But for degrees, they must have like degree symbol there. Otherwise, it's just radian, okay? So one thing that I want you to know, by the way, is radian is actually unitless. So radian is actually not a unit. For example, you see how the definition of angle was L divided by R? So this was like, if this is a certain centimeter over centimeter, what's going to happen to these two? They're just going to cancel out. So radian measure is actually unitless. Okay? Any questions so far? Anyone? Now we're going to try another problem. So this is from Google, that's right. So we're going to move on to this one. So we know L equals R theta now. We know that area is equal to half R squared theta. Now this one, by the way, is a bit tricky. So it's about just that area there. So that's given by this formula. We're going to go through that later. Okay. So I'm going to maybe save this one because it's not loading anymore. Okay. We're going to try this. We're going to just go through this example. So you have 12 centimeter of radius and the angle is 1.5 radians. And what is the arc length here? The answer is simply just 12 times by 1.5. That's how you get 18. So this is 18 centimeter. Here you have 40 degrees and this one is 12 centimeter. So how much is the arc length? You have to, so this is 12 times by the angle. Well, the angle of 40 degrees, this whole thing is 40 degrees being converted into radians, right? So that's 40 pi over 180. Okay, so that's how you get this one here. This is another question. This is 8 centimeter and the radius is 10 centimeter. So how much is the angle? It's very simple. Angle is divided by the arc length divided by the radius. True? So that's just 8 on 10. So 8 on 10, which is 0.8, that's the angle right over here in radians though. But how much is it in degrees and minutes? So let's have a look. So you have 0.8. Let me just write it down. So you've got some shape like this. This is 8. This is 10. So how much is this angle? This angle is simply L over R. So that's 8 divided by 10. So this is 0.8. Now you can convert 0.8 radians, that's radians, into degrees by multiplying this by 180 over pi. So you can just evaluate that in, just plug it into calculator. So 0.8, 180 divided by pi. So it's about 45.8 45.836, right? 45.8366. Something like that. So you can convert. So this is 45 degrees. So you can say this is 45.8366 degrees, but they want minute, right? But you have to know that in 1 degree there are 60 minutes, and in 1 minute there are 60 seconds. So that makes sense, right? In 1 hour there are 60 minutes, and in 1 minute there are 60 seconds. So degree is sort of equal to hour. All right, that's sort of equivalent. So you can see that this is how much is 0.8366. So this is equal, just take away 45, then you get these are the decimals, right? So we have this many degrees. So how much is that in? So if you've got 0.8366 hour, how much is that in minutes? So we know that 1 hour is equal to minutes, right? 60 minutes, right? So how much is 0.8366 hour in minutes? So I want you to figure this one out. I think it's pretty easy. You can use the knowledge of the unit conversion that we went through to figure this one out. I'll give you some time for it. I'll be right back. Okay, so Chris has got an answer. Let's just double check. So if you want to convert let me just change my color. 0.8366 hour into minutes, then you have to multiply by minute down here, hour down here, and minute up here, right? So that hour and hour cancels out. So this is a conversion factor, and of course you know that 1 hour is equivalent to 60 minutes, right? So you just all you have to do is just put on the top and bottom the things that are equivalent. So 1 hour is equivalent to 60 minutes. So if you do that, so that's this one times by 60, then you get 50.1974. So this is a 50.1974 minutes. So your answer, 45.8366 degrees, is 45 degrees, and 50 minutes. All right, 45 degrees and 50 minutes. And then what do you have to do with this 0.1974? Well, just take away 50 from here, then you get decimals. Hold on. So that's the decimals. So we got this many minutes. So we can also convert that into seconds, right? So times this by 60 again. All right, then you get 11 seconds. 11 points. So if you round it up, it's about 12 seconds, right? So if you're only doing up to seconds, then you get 12 seconds. Okay, so we multiplied this one by 60 minutes to get minutes, and you get 0.1974 minutes. You can multiply that by, that 1 minute is equal to 60 seconds. Then you get the amount of seconds, right? So minute and minute cancels out. So this one can be converted into this one right here. So you can actually use, there is a special button in your calculator that mine doesn't seem to have it. Do you guys see in your calculator like this button, this symbol, and then like this symbol and this symbol? Can you see? Can you say, yeah? Do you see that? So I want you to maybe just type 45.8366. Just type that in, like just delete everything, and then 45.8366. Okay. And then after that, can you press this button and see what you get? Does that give you this value? Yes or no? So it gives you 45, 50, and 11.76 seconds, right? Okay, that's excellent. So there's an automatic button there you can use. Lizzie, did you get this one as well using this button? Okay. Right, now we're gonna move on to the next example. So this is about area. Oh no, this is about the angle, that's right. And this is about area, and you can see this is a half. So this is just using the formula. Half r squared theta. So this is a half, and you can see that the radius is 10, so 10 squared is 100. And times by the angle, of course, this has to be in radians. When you're using this formula and this formula, you always have to make sure that the angle is in radians, okay? So you get 40 centimeters square. Now we're going to try, we're going to skip this one. Maybe we'll try these questions here. So they're not so bad, they're pretty easy. All you have to do is just use these two formulas. The number one is angle equals to L over R. Area is equal to half r squared theta. That's all you have to use. Now let's look at number one. It says calculate in degrees and minutes the magnitude of the angle. So the size of the angle, that's what they're talking about. So size of the angle subtended at the center of a circle of radius 8 and arc length by an arc whose length is 15. So all they're saying is you got a sector, and this radius is 8 and the arc length is 15. So they want you to figure out the angle in degrees. Okay, so I want you to try that. Can you guys still draw? Can you guys still draw this thing with this thing here? Do you have drawing capability, Chris? Can you try? Does it work? If it doesn't work, you can just do it on your yeah, maybe they got rid of it. Yeah, you can try this on your own and then type your answer. By the way, if you want to get the drawing capability back, you know, the Bliss has been updated recently. So if you go into options, and if you see this one, it says a use new user interface, right? So you have to untick that one. So if it's ticked, then you'll be using an updated version. If you do, if you untick that one, you know, just in case your this is only for when your Bliss has been updated recently. Okay. So I would not recommend using the new user interface. So untick that one and click OK. Then you will go back to the older version of Bliss with these little boxes floating around. Then you get the drawing capability back. Okay, the drawing function. So do not use the new user interface. That's a really bad one. Okay, so what's the angle right here? So the angle here is 15 over 8, isn't it? 15 over 8. So that's equal to, that's in radians, right? So you can convert that into degrees by 15 over 8 times by 180 divided by pi. True, so that's radian and radian cancels out. You get everything in degrees. So this one is 15 over 8 times by 180 divided by pi. So I'm not going to do it in exact form. I just want the angles. Maybe I should have done it more exactly because I need to convert into decimal places. I mean degrees and all that stuff. So 15 divided by 8 times by 180 and then divided by pi. Enter. So it's a 107.4 blah blah blah, 107.429 blah blah blah. Maybe it doesn't work for me. Maybe you guys can just press that button and see what you get. So for me, I have to minus 107 from here. So 0.4295866 times that by 60. Then I get the minutes. So this is 107 degrees and 25 minutes. And minus 25 from here, and this one times by 60 again, then I get 46, about 47 if I round it up. 47 seconds. Let's move on to the next question. Was question 1 alright for you guys all? Okay, good. Let's move on to number 2. Question 2. Find the length of an arc of a circle of radius 15 whose subtends an angle of 70 degrees at the center. So this is you've got 70 degrees here, and it's got an radius of 15. So what is this length right there? So we know that the L is equal to r theta, but this theta has to be in radians. So I want you to use this formula, but you have to convert this into radians, okay? So you don't put 15 times by 70 like this, all right? So it's not going to be 70. So I give you 1 minute for that as well. I want you to type your answer. I'll give you more clue. So you can convert degrees. You can convert degrees into radians by multiplying by, so that's radians here, by 180 down here and pi, okay? So that's in degrees. You multiply the degrees by this one, then you get the radians, and you put that right there. Then you can figure it out, okay? I'll just wait for you guys to come up with an answer. Lizzie, have you worked it out?
Kinda.
Kinda? Okay, Chris has got 18. Do you agree with that?
Yeah, that's what I've got.
Okay, Philip, what about you? Did you work it out some similar value as well? No? Okay, so here's how you do it. So this is 70 degrees here. Multiply that by pi over 180. Then you get 70 pi over 180, right? So you can actually cancel these zeros. So divide by 10, divide by 10. And this is 7 pi over 18. So that's the measurement. So this is 70 degrees right there. But 70 degrees is same as 7 pi over 18 right there, okay? So we multiply 15 by this one. So 15 by this angle. That's the formula right there. 7 pi over 18. So that's the answer. So this is equal to, 15 times by 7 is equal to 105. So this is 105 pi over 18. So you can just leave your answer like that, or put it into the calculator. So this is 105 times by about 3.14 divided by 18. Then you get 18 point about, something like that, 32, 18.32. And this, if this was a, what did I put degrees there? This is in centimeter, isn't it? Yeah, centimeter. That's right. So this is in centimeter as well. That's the length over here. Let's move on to question 3. This one here. So we did this one, this one, this one. So arc length of a circle subtends an angle of 100 degrees at the center. If the radius length of the circle is 12 centimeter, calculate the arc length in terms of pi. So it says in terms of pi. So what this means is they want an exact answer, no decimals. All right, I'm just going to draw this for you. So it's a circle with an angle of 100. 100 is more than 90, so it's about like that. So this is 100 degrees there. And the radius length of the circle is 12. So that's 12 centimeters. So what is the arc length? That's L. So try this again. L equals r theta. Okay, so give that a go. Okay, so R is 12. The angle is 100, but you got to convert the 100 just as you convert 70 into radians. Multiply that by pi over 180. So that's the rule. So this would be 10 pi over 18. Or if you simplify this, this is 5 pi over 9. So the answer is 12 times this 100 degrees in radians is equal to 5 pi over 9. So you can see that 12 and 9 cancels out with the 3 and 4. So this is a 20 pi over 3. And we just leave it like that. That's the most simplified form, isn't it? So the L is 20 pi over 3. I'm going to give you maybe another question. Say this is 100 degrees here, but instead of the radius being 12, let's suppose that the arc length, this here, is 12. I want you to figure out the radius. Okay? So you have to still use this equation though, okay? So give that a go. I'll give you maybe 2 minutes to try. I think you guys all understood the previous question here, so maybe try this one. It's a bit trickier. Okay, so you know that 100 degrees is the same as we worked it out before, 5 pi over 9, right? So you got to use this one. I want you to work out the R in exact form. In exact form as before. So in terms of pi, okay? Anyone got an answer? Chris, Lizzie, Philip? Still working? Chris, are you still working on it? Lizzie? Okay, give you more time. Yeah, so you can see that this is L equals to R theta. So we are working out R, right? So R is equal to L over theta, right? So that's the formula you have to use in this case, true? Because we are working out the R. So R is exactly L over theta. You're right, Chris. And L is 12, isn't it? So it's nearly there, you know? So it's 12 over this angle right here. So 5 pi over 9. So, but you have to simplify this one. Okay? That's the answer. I want you to simplify that. I'll give you a clue, all right? So if you have like a A over B over C over D, the answer is AD over BC. So these two, numerator these two on the denominator. Okay, so you have to simplify this. Lizzie, have you already got the answer?
I'm just simplifying it.
Okay, so yeah, simplify this one. Chris as well, Philip as well. Simplify this using this formula. Yeah, that's right. So 9, so this is 12 over 1, isn't it? So it's a 12 times by 9 on top, and 1 times by 5 pi, which is 5 pi on the bottom. So what's this one times by this one? This is 108 over 5 pi. That's exactly the answer. That's right. So this is an exact form. But if you don't want the exact form, then you can just put it all into calculator and get decimals. But this is about 3.14, right? Okay, we're going to try another question. We're going to try so we tried number 3. Oh, it's all in here, right? Number 4, we're going to try number 4. Okay. So area of sector AOB. So this is A. I think this is O, this is A, this is B. So this is part of a circle. Has got radius length of 20, so this is 20 right there, 20 centimeter, and has got area of 240. So area is equal to 240 centimeters square. What is the magnitude of the angle? So what's the angle right here? And what is the length of this right here? This is L. What is the length of the chord? Let's not worry about this one because we didn't go through that. Okay. So I want you to try this. Just gonna erase a little bit here. We need some space. Okay. So the formula that we need is half r squared theta, right? We didn't prove this one, but we can use this one still. So the area here is 240. And it's half, and the radius is 20, right? So this is a 20 square. And theta. So you can work out the theta. I'll give you 30 seconds for this one. $20 squared, by the way, is 400. So this is 400. Yeah, 400. So this is 400 times by half, which is 200. So this is 200 right there. So theta is equal to 240 divided by 200. So which is equal to 240 divided by 200, which is equal to 1.2. So would that be in radians or degrees? Radians, that's right. Yes, so this is radians. So radians doesn't always have to involve pi in it, okay? So that's the angle. Now I want you to figure out the arc length of this one. So that length right there. So you have to use the theta equals to L over R, or if you rearrange that, L is equal to R theta, right? So multiply that along, so you have to use this formula. Okay, have a go. So r is, by the way, I think 20. Lizzie, do you have the answer for this one? How much do you think this one is? As soon as you get the answer, you can just tell me.
Am I keeping it in radians? Or
yeah, always radians, always.
So just
when you're using this formula, you always have to use radians, this formula as well. So the answer is, so Chris is saying the length is 68.75. I'm not sure how he got it. The answer is 20. So this one 20 times by 1.2. The angle is 1.2, right? So how much is that? It's 24. 24 centimeter. Chris, do you understand this? Philip, do you understand this? Philip, you still there? Kind of understand this? Okay, good. Now let's move on to number 5. Chord. Oh, this is about chord. Okay. I think we should just skip these questions and then move on to other questions that we tried earlier. Okay, so now we're going to move on to some of the earlier, not these ones, but the ones we tried earlier. So that's part 2. That's part 2, okay. All right, so these are a bit difficult ones in terms of the pi, radians, and things like that, but I think we should still try them. Okay. Yeah, I think we should still try them. So they are quite difficult, but yeah. Okay. Let me zoom out a bit and see if we have enough space. Yep, we have some space down there. All right. So let's talk about, so sine of theta is 0.6 and cosine of theta is 0.8. Question A, what is sine of pi minus theta? We know that pi is how much? Pi is the same as 180, true? So we're going to imagine, you can see that because sine is positive, you can see that this is positive. And the cosine theta is also positive, right? So we know that the theta, whatever this angle is, it must be on which quadrant? The first quadrant, or the second quadrant, or the third one, or the fourth one? Which one? It must be on the first quadrant. Well done, Chris, though. Good try. Because everything is positive. Only sine is positive, tangent is positive, and cosine is positive. All sine, tan, cos, right? Or cats, C-A-T-S. So we know that this angle here is an acute angle. So what is an acute angle? Angle that is between 90 degrees and 0 degrees. So these are the conditions that's given, and we know that the angle is somewhere here. So that's the angle, and that's the triangle. So whatever this angle is, sine of theta is 0.6. So this could be like, that means this is 0.6 is 6 over 10, right? So 0.6 is like 6 over 10. So you have like a triangle here, and the ratio of this divided by this is like 6 on 10. This is 10, this is 6. And this is cosine theta is 0.8, so this is like 8 on 10. And that actually makes sense because if you actually divide all this by 2, then you get like 3, 4, 5 triangles. So they actually satisfy the Pythagoras theorem, you know, because like 3 square, 4 square equals 5 square. And this one here is 6 square, 8 square is actually 10 square, right? So they gave you that. Based on that, you can actually think that there is a triangle on the first quadrant, like this. But of course, if you have like the second quadrant, like over here, this would be still 10, this would be 6, this would be minus 8. And if you have like a triangle like this way, and this would be 10, this is still minus 8, this would be minus 6. And this one over here, then this would be 8, but this would be minus 6, and this would be still 10. All right. Now, let's think about this one, sine of 180 minus theta. So we go 180 first. That's 180, and then minus theta, so we have to go back theta much. So we can draw a triangle like this. So this angle here is theta, right? So this is a theta, right? So there are two ways of thinking about it. Number one, so using the technique that I taught you before, so this is sine of, this is sine of this angle right here. So this is sine of the same thing as theta. So you can just put theta there instead of pi. And because sine is positive over here, the answer is positive. So the answer is, whatever this is, the answer is 0.6. The sine of, so this one here is the same as this one, 0.6. Another way of looking at it is, you know how I drew this triangle before? Now the triangle is this one right here. What's the sine of whatever this angle is? That's equal to just that over that. So that's a 6 on 10, which is 0.6. That's the opposite over hypotenuse. So sine of, you know, whatever this is, that's the opposite over a hypotenuse. So that's equal to 6 on 10. So you get 0.6. So that's another way of looking at it, okay? Let's try next question. So this is a B, sine of pi plus theta. Let's try B. Sine of pi plus theta. So where would that be? Would that be on the first quadrant or second quadrant or third quadrant? That would be on the third quadrant. 1, 2, 3. So it's 180. So that's pi plus theta much. Theta. Okay, and you have a triangle like this. So whatever this is the same as sine of theta. Of that. Because you as long as you work out the angle inside the triangle that's one of the bow tie shape, whatever that is, that's going to be equal to sine of that particular angle. But this is where the tangent is positive, so this is negative. So the answer is negative 0.6. I want you to try maybe the next one yourself. So this one here, C. Sine of 2 pi minus theta. Now 2 pi is 360. Okay. So rule number 1 is find the branch. Where is the branch? Okay. So where would be the branch? So 2 pi is actually 360. So you go 360, and then you have to take away theta. Lizzie, where would the branch be?
In the third quadrant.
In the third? Chris, what about you? What do you think? Fourth? That's right. So this is 360
Oh, yeah. Sorry.
and then minus theta. So you're right there. 360 but less theta. And you draw a triangle like that, and that's theta, right? So because you worked out this triangle, sine of whatever this is going to be sine of that angle. That's theta, true? Is it going to be plus or minus? Anyone? Minus. Negative. Because it is A, S, T, C. Only cosine is positive, right? So the answer is negative 0.6. So that's the answer for C. Let's move on to D. Sine of negative theta. D. Sine of negative theta. Here's the clue. If you have a sine of 30 degree, you go forward. This is anti-clockwise. So anti-clockwise is forward. If you have sine of negative 30, you go backward, which is clockwise. Understand? So therefore, you have sine of negative 30, so you have to go backward. So you are going backward. And this is theta, true? So I want you to figure out the answer. So what would this be? Sine of what? I'll be right back. All right, did you guys work it out? So sine of negative 30 is like this one. So the angle is theta, so this is equivalent to theta, sine theta, without any negative. Okay? And because this is now in the, this is A, S, T, C, only cosine is positive. So we started with sine, so it must be negative. All right? So the answer is, so this negative sign doesn't automatically come out. You have to actually figure this one out yourself. I'll show you the case for cosine later in a minute. So negative sine theta is equal to, what's the sine theta, by the way? Sine theta is 0.6. So the answer is 0.6. So here's another question. Maybe D dash. I'm going to try this question here with you. So if you have cosine of negative theta, however, then the angle is going backward, we know, this way. And this angle here is theta, right? So the answer is, this is cosine of theta. And then you have to figure whether it's positive or negative. But cosine is positive here, right? So you have to put a positive sign here. So you don't need any positive sign, you just have to put nothing there. So the answer is just like that, and then you get cosine theta is equal to, here it's given as 0.8, wasn't it? Like that, so it's 0.8. Okay.